Good evening, everybody. You may remember in the last lecture I was discussing the very basics of the structure of the modern periodic table. As you can see out here, the modern periodic table of elements is also known as the long form of the periodic table of elements. Mendeleev's periodic table was also and is also known as the short form of the periodic table of elements. Please remember this because I'm not so sure whether this is mentioned in your textbook. Now, the periodic table, henceforth, when I refer to it, I will be talking about the modern periodic table, is divided into, if you see, vertical columns. And how many vertical columns do you see? We discussed this last time, from 1 to 18. So there are 18 vertical columns. What are these columns called? Each of these columns is called a group. So there are 18 groups, starting from the number 1 right up till the number 18. And if you see, there are horizontal rows. There's the first row, that's the second row, and that's the third row, and so on and so forth. So you have these horizontal rows which are known as periods. So you have, as you notice carefully right now, 7 such periods in the modern periodic table. To recollect, there are 18 vertical columns which are known as groups, 7 horizontal rows which are known as periods. We'll start with groups first because we had already discussed that the groups can be named in 2 different ways. The first way of naming a group, like group 1, I had given you another name and that was group 1A. 2 is 2A, that is group number 2 is also called 2A. Group number 3 is not 3A, it's 3B. Group number 4, 4B. Group number 5, 5B. Group number 6, 6B. Group number 7, 7B. All well up till here, except for the fact that the A's have become B's from 3rd onwards. Then you have a strange thing. Group number 8, group number 8, group number 8. So you have 3 groups which are called group number 8. And then when you go to group number 11, that becomes 1B. Group number 12 becomes 2B. So if you look carefully, 1B, 2B, 3B, 4B, 5B, 6B, 7B. So all the B's have actually been covered in this middle region of the modern periodic table. So what about the A groups? If you remember again, go back, 1A, 2A, and then after 2B, group number 13 becomes 3A. You can easily remember that because 13 ka 3 yaad karo, so 3A. 14 ka 4 yaad karo, to 4A. 15 ka 5 yaad karo, to 5A. Similarly, 17 का 7 याद करो तो 7A, लेकिन 18th group का नाम क्या दिया है? They've been given a name called zero group. I hope this is very clear because on the basis of this, I'm going to be starting my lecture today. 18 vertical columns known as groups. 7 horizontal rows known as periods. Now we'll take one period at a time. Pay attention very, very carefully because this is what is going to lead to the rest of the chapter. If you look at period number 1, the very first element of period number 1 is hydrogen. Its atomic number is 1. For those who do not remember, the atomic number and not the atomic mass. The atomic number and not the atomic mass is the fundamental quality of any atom of any element. Going back to period number 1, in period number 1 you find element hydrogen having atomic number 1. Then there's a lot of empty space which is not visible out here, but I have given you, if you notice, the IUPAC version of the modern periodic table. It would be perhaps absolutely blank out there, and you have the second element, that is helium, which has atomic number 2. So in the entire group in the entire period 1, you have just 2 elements. The first element is hydrogen, the last element is helium. It's also known henceforth as the shortest period in the modern periodic table. Let's go to period number 2. I am assuming period number 1 is very clear because it's so very simple and straightforward. Period number 2, you have 1, 2, 3, 4, 5, 6, 7, 8 elements. So let's go one by one. You have lithium, beryllium, then you have boron, carbon, nitrogen. I hope you're looking at the atomic numbers. They're all going in a very proper increasing order. Nitrogen 7, oxygen 8, fluorine 9, and neon 10. So let's revise again. Let's have a look again. The first period had only 2 elements. One was hydrogen and one was helium. The second period had 8 elements. Lithium, atomic number 3, beryllium, atomic number 4, going on from there till neon, atomic number 10. The third period, if you notice carefully, again has, look carefully, sodium 11, magnesium 12, so that makes it 2 elements. Then you jump to aluminium because there's empty space in between. So aluminium is atomic number 13. The next one, silicon, is atomic number 14, phosphorus atomic number 15, sulfur 16, chlorine 17, and argon 18. Now, in the first period, we had 2 elements. Second period, 8 elements. Third period, 8 elements. Let's go to the fourth period and look only at the first 2 elements, and that is potassium and calcium. If you remember, I had asked you all to perfect the first 20 elements because of a particular reason. And one of the reasons, which you've already studied from the study material provided to you, is that Newland's octaves were found to be true only up till calcium. After that, the elements were not found to be similar to the element on top. And that's where he, in a sense, goofed up his entire table. And then came Mendeleev and he said, okay, fine, if there's nothing on top, I'm going to create a new vertical column and a new vertical column and a new vertical column and a new... And he had patience because he had to go right up till atomic number 31, which, if I'm not mistaken, was a blank space. He couldn't find anything similar in 31 also. So he went on till he found the first similar element. In all probability, that was germanium or arsenic. So let's go back to 20 because that's what we need to discuss first. Let's go back to 1 because we'll start from 1 again. First period. Let's not look at only the atomic number. To revise, atomic number is the number of protons or electrons found in an atom of an element. That's page 1 of your notes. So if hydrogen has electronic configuration 1, how many electrons will it have? It will have 1 electron. And if it has only 1 electron, how many orbits will it have? It will have 1 orbit. Helium. Atomic number 2. Electronic configuration 2. Because the first orbit, which is the smallest orbit, can hold 2 electrons. Let's go to the second period. Now, before I speak, I'll give you small pauses for you to revise your electronic configurations. Lithium, what will be the electronic configuration? 2,1. Beryllium, 2,2. Boron, 2,3. Carbon, 2,4. Nitrogen, 2,5. Oxygen, 2,6. Fluorine, 2,7. And neon, 2,8. So this was just 1 and 2. This was 2,1, 2,2, 2,3, 2,4, 2,5, 2,6, 2,7, 2,8. Let's go to the third period. Sodium, atomic number 11. So you give me the configuration. Those who have said that it is 281 are correct. If you've come up with any interesting answers other than that, you are unfortunately incorrect. Magnesium, 282. Aluminium, 283. If you've got the hang of it, this is 284, 285, 286, 287, 288. Let's go to period number 4, but deal only with the first two groups. So you have potassium, which has an atomic number 19. Try to guess the electronic configuration if you don't already know it. Okay, those who have guessed 2881. So 2 plus 8 becomes 10, plus 8 becomes 18, plus 1 becomes 19, and that's correct. Let's check calcium. I think you would have got it by now. 2882. 2 plus 8, 10, plus 2, plus 8, that would become 18, plus 2 becomes 20. We stop there. Now you might say, sir, you're just telling us what we already know. Many of you might be saying that. But I want you to have a look again at what's happening in period 1, what's happening in period 2, and what's happening in period 3. There were certain facts which I asked you all to mug up over the last few days, actually more than a week, and those things which you were supposed to mug up are for better understanding of the modern periodic table, which we are doing right now. So what does period number 1 suggest to you? So you'll say, okay, fine, we know that period number 1 has two elements, one is hydrogen and one is helium. It's the shortest period. So electronic configuration is 1, electronic configuration is 2. So my question to all of you, in case you've not already realized it, is simply how many orbits or how many shells does hydrogen have? You'll see obviously hydrogen has only one shell because it has only one electron. And you will also say helium has two electrons and the first orbit can hold two electrons. So it has one shell as well. So period 1 has two elements and both of them have just one single shell. Let's go to period 2. What was the lithium electronic configuration? Repeat in your minds. It was 2,1. That means first shell में कितने electrons थे? There were 2 electrons and second shell में 1 electron. यहाँ पे first shell 2 electrons, second shell 2 electrons. Then there was 2,3, 2,4, 2,5, 2,6, 2,7, 2,8. Now what's the similarity in all these elements that you see out here? They all have not one shell but 2 shells, each one of them starting from lithium and going up to neon have 2 shells each. So period 1 had 1 shell, period 2 had 2 shells. Period 3, what was sodium electronic configuration? Try to recollect. It was 281. That is 2, 8, 1. That is 2 in the first orbit, 8 in the second orbit, and 1 in the third orbit. 2, 8, 2. 2 in the first orbit, 8 in the second orbit, and 2 in the third orbit. Then it became 283, 284, 285, 286, 287, 288. So period number 3 has elements starting from sodium going right up till argon, which have 3 shells each. Now if you look carefully, period number 3 has 3 shells. Period number 2 has 2 shells. Period number 1 has 1 shell. If you look carefully, 2n square is what we were discussing a little while back. So 2 into 1 square, there were 2 elements in the first period. 2 into 2 square, there were 2 into 2 square became 2 into 4, which became 8. 8 elements not only in the second period but also in the third period. Now who would like to guess how many would be there in the fourth period? In the fourth period, as you can see, there are so many new vertical columns which have come. But what had Niels Bohr predicted? When there is an increase in one more shell, that means it will become how much? His formula was, everybody, 2n square. So now it become 2 into, since there are 3 shells, 2 into 3 square. How much is 3 square? 3 square is 9. 2 into 9, 18. You want to count? So that's 1, 2. Actually, you don't have to, because this is your first group. And if you look carefully here, krypton is in group number 18. Now, if you realize what Niels Bohr had predicted as the maximum number of electrons are actually present in each of these examples. So what's the moral of the story? We don't need to go ahead. It's not in your syllabus. What's the moral of the story? The period number determines what? So if I say some कोई तो एक element है, चलो वो period number 2 में, तो उसके पास कितने shells रहेंगे? Immediately आप बोलना चाहिए दो shells रहेंगे. Period number 3 में है, तो 2 shell रहेंगे, 3 shell रहेंगे. Period number 4 जो है, 4 shell रहेंगे. Hello.